Today we are starting to talk about systems of equations. Okay? That's the new unit that we're talking about today. And I have to be honest with you about this unit. It is my very favorite unit to teach. It's not that I don't like the others, it's that this one's my favorite. Okay? I like the other ones a lot. This one's my favorite. Okay? So, what is a system of equations? What does that even mean? Well, think about this. We have a gaggle of geese. We have a herd of sheep. We have a flock of birds. We have, what, a school of fish? And we have a system of equations. What does that mean? A group of equations, right? More than one equation. Okay? The wolf pack, okay? All right. So if a system of equations is more than one equation, what does that mean? Nothing? You got nothing? All right, I'll ask again in a second. We'll talk a little bit more, and then I'll ask again in a second. Okay? Systems of equations, part of the reason that it's my favorite one to teach is it's one of those things where, you know, teachers are always telling you, oh, you'll use this outside of my classroom, and then you're like, never. You never do, right? This is one of the things that you will use. You may not sit down with a piece of paper and a pencil and a calculator and write down an equation, but your thought process that you use to solve systems of equations is what you'll use. Okay? Now, for now, you're just going to have to trust me on that. Okay? Later on, when we get to like the specific word problems and stuff, you will hopefully see what I mean. All right? When we build in those real world problems into our lessons, you'll see what I mean. Okay? There's at least 4 different ways to solve a system of equations. At least 4, I say, because we're going to study 4 different ways to solve a system of equations. Okay? There's some other things that you can do. We're not going to. We're just going to do the 4. All right? So I want you to think about this. If you have an equation like this, y equals 2x plus 3. Okay? Y equals 2x plus 3. What can you do with that equation?
Solve it.
How? How can you solve it? You know how to solve that equation? Yes, sir? And do what with it? Oh, graph it? Who said that? That's exactly right. This equation you could graph, right? Is that a system of equations? Why not? Because there's only one, okay? But what if I said y equals, I don't know, 1/2 x minus 4. And then I put this really pretty bracket around it. Is that a system of equations? Yes. How many equations do I have in my system? How many variables do I have in my system? Do you think that's a coincidence? No. Okay? One of the things that I want you to know about a system of equations is that the amount of variables you have will tell you how many equations that you have to solve it. We have 2 variables, x and y. Therefore, we need at least 2 equations to solve the system. If we had 4 variables, we would need at least 4 equations to solve the system. What if I had 7 variables? I need at least 7 equations to solve the system. Okay? Now, before I scare you a little too much, all we're going to do is 2 and 3. And we're going to work on 2 for a good while so that most of us get it. Or, I mean, I'd love for all of us to get it. Hopefully most of us get it, though, before we go on to 3. Okay? The more variables you add, the more difficult the problems get. The more involved they get. Okay? So like I said, we're going to start with 2, and then we'll go to 3. There may be one that shows up like as an extra credit on a test that's 4 or 5. But by that time, you'll own it. You'll know exactly what to do. Okay? So I told you there's 4 different ways that we're going to look at to solve systems of equations. Okay? What do you think the first way is? What did we just talk about? Graphing, right? Okay? If I graphed this first equation right here, what shape does that make? A line. Thank you. Okay? What shape does the second one make? A line. So what would happen if I graph these two lines? I'd have two lines. How would I tell what the solution is? Well, where they cross? Where they intersect? That's exactly right. Okay? So one of the things I need you to know is that a system of equations is more than one equation. Okay? One of the things that I need you to know is that if you have two variables, you need two equations to solve it. If you have three variables, you need at least three equations to solve it. So the number of variables will tell you how many equations you need to solve it. The next thing I need you to know that's really, really important is that the answer or the solution to a system of equations is where the two lines intersect. Okay? And what's that called? How about a point? A point, right? It's a point of intersection. So how would we write our answer? What do you mean by that? Yeah, like 1, 5 or something. Or 3, -6 or 2, 12. Those would all be examples of solutions to systems like this. Just to be clear, I'm pretty sure not one of these is the actual point of intersection for these two lines. But this is how we'd write our point. Okay? Did you come to algebra today prepared for your mind to be blown? Because if you didn't, go ahead and prepare now. Okay, that's all the time you get. You ready? So, what about an equation like this? X plus y plus z equals 8. How many variables? 3 variables. So how many equations am I going to need to have? At least 3, right? At least 3. Sorry. But I thought I said a minute ago that, like, it would be the answer would be where they intersect. Do you know how to graph this? That would imply that we had an x-axis here, a y-axis here, and a z-axis. Hey, guess we do. It goes like this. It goes straight perpendicular through the paper. That's the z-axis. Okay, not yet. It's not time for your mind to be blown yet. Because can we graph that? Can we graph on the z-axis? Watch me. Can you tell that that one's sticking out from the paper? It's like going right through the paper at a little angle. So what if my solution was like 2, let's make it easy, 2, 3, 1. I'd go right 2, up 3, and out 1. Now it's good. Right 2 on the x-axis, up 3 on the y-axis, and out 1 on the on the z-axis. So like if we had an x-axis here and a y-axis here, and I was doing it I could go out 2 or right 2, up 3, and out 1, and the answer would be right at the tip of my pencil. My pencil's not on the paper. See how it's up higher? Can you tell that? Now you can when you look at my pencil, right? It's hard by looking at the screen. Okay? Look, I'll put my finger underneath it. It's not. I'm not stabbing myself, I promise. Okay? No blood. So to put your mind at ease, we're not going to be graphing these. with 3 variables. But my point is, could we? Okay, so tell me what is my solution? A point of intersection. Even when there's 3 dimensions, do you see that this is 3-dimensional space? If I have 3 variables, x is right, left and right, y is up and down, z is out from the paper or in through the paper. Yes? Okay? So, is it still a point? Okay? A point like this is what we're used to, right? X comma y. What's that called? So what happens with that? Why is this called an ordered pair? Because it's in some sort of order and it's a pair of numbers. 2. So it would be a ordered triple. Ordered triple is exactly right. Okay? So tell me what a system of equations is. Remember I told you, I asked it a minute ago and you didn't know, so I'm now asking it again. 2 or more equations. Okay? Where is the solution? The point of intersection. Even if it's 2-dimensional or 3-dimensional, it's still a point of intersection, right? What about, like how many equations do I have to have in a system of equations? As many variables as I have, right? So here comes the question that you've all been waiting for. What happens when I have w, x, y, and z? Can you graph in 4 dimensions? First of all, you have to have 4 equations, right? Can you graph in 4 dimensions? I can't. I mean, I don't know how to. Maybe Mr. Fuquay does? Probably Mr. Fuquay does? Yeah? Okay. Ask him. Ask him if it's even possible. Okay? But regardless of that fact, if we had 4 equations and 4 variables, how would I write my answer? W, X, Y, Z. Thank you. Okay? Any questions so far? Okay. So where I want to start is that worksheet I gave you called System of Equations. Okay? Systems of equations. Now, I told you, since we're struggling right now with word problems, I told you we're going to start right off with that. With systems of equations, a lot of times I don't use x and y. I do when it's given to me, but if I have a choice and it comes from a problem like this, I want to use what we call meaningful variables. Variables that mean something in the context of the problem. I don't want to write 2x plus 3y equals 18. I want to write 2s plus 3b equals 18. Am I allowed to use letters other than x and y? Absolutely. Why did I write 2s? 2 sodas, right? Why did I write 3b? 3 burgers. Does that make sense? So somebody tell me what the next one would be. (5s plus 6b equals 39). Very good. Somebody else, tell me the next one. (2b plus 3f plus 2s equals 18). Very good. And somebody else, tell me the last one. (2n plus 3b plus 2f plus 4s equals 38). Except I wrote 9. That was weird. Guys, you just did a word problem. Do you realize that? Now we haven't solved it or answered it because we're not there yet. But you just pulled information from words into numbers. Can I build your confidence a little bit? You just did it. Okay? So let's give ourselves some definitions. When used together, these equations form a system of equations. And a system of equations is when a set of two or more equations with two or more unknowns. Okay? So, second definition. The blank to a system lists the values that can be used for each variable to make the equations in the system true. What do you think? Excellent. Solution. Okay? So let me go off on a small tangent just for a second. Okay? Any of you guys build anything? Nolan, what do you build? Barns? You build barns out of wood? So it's time to go to the wood store. Okay, Lowe's, whatever. Lumber yard. And you have to buy some wood. What kind of wood do you buy? 2x4s, 2x8s. Okay, the point I'm trying to make here is that you don't go into the wood store or the lumber yard, whatever you want to call it, and say, I need some 8s. Because they would look at you like you were an idiot. Especially if what you really meant was 2x4s. Right? What's 2x4 look like? Not the actual wood, but the words. 2x4, right? So if you go to the wood store and say, I need some 8s, they're going to get you a padded jacket and put you in a padded truck, send you to a padded room. Okay? So how do you know not to call it an 8? Even though 2 times 4 is 8. How do you know? It's basic knowledge. You just know that, right? For the same reason that when we're naming systems of equations, how many equations do we have here? 3 equations. How many variables do I have here? 3. This is called a 3 by 3 system. I don't say it's a 9, do I? I say it's a 3 by 3 system of equations. And why do I say it's a 3 by 3 system of equations? Because it uses 3 variables and has 3 equations. That was a good guess. Okay? Which of the following would be the solution to this system? How do we decide if it's a solution to the system? What do you think? No guess? Say it again. The answers to all the variables. So if I say, is this a solution? How do you decide if it's a solution or not? What do you mean by try it? So like substitution? Substitute all these values in to where they go. So if I say, try this one, where would you start? So you'd start right here? So where would you want to start? If you can start wherever you want, where would you want to start? Because see, I would start in the middle one. Because it's easier, right? Don't we always want to do the easiest stuff? That's not a bad thing. Okay? So if I started here, -4 minus 2. What is -4 minus 2? So -6 equals 4? Does -6 equal 4? Is this a solution? Could this be a solution to this system if it does not work in one of the equations? No. Okay? So if I say you have A to try, B to try, and C to try, what would you do next? Would you try B? Somebody over here said they would try C. Why would you try C instead first? There's no decimals, right? There's no decimals. You guys love decimals, and by that I mean the opposite, right? No. Okay. X is 5. 5 minus 1 is 4. Is 5 minus 1 4? So that means C is the answer. I don't know that yet, but I just know I know 5 minus 1 is 4. It only works in one. How do I know if it's truly the solution? If it works in all of them. Very good. Okay, so let's try the first one. 2 times 5, 10. 3 times negative 3. So 10 and negative 9 is 1. Negative 4 times 1? Negative 4. So I have 1 and negative 4. Is that negative 3? So it works in this one too. So that it really must be the answer. No. What do I have to do? Plug it in the last one. Okay? So negative 5. I have a negative 2 times a negative 3, which is 6. So I have negative 5 and positive 6. 1. Very good. And then I have 3 times 1. 3. So 1 plus 3. Does it work? Yeah. So if it says which of the following would be the solution to this system, do we try B? No. Just wants one solution, right? Okay. So let me come back here real quick to this piece of paper real quick. If we're graphing lines, so we have a 2 by 2 system. Nolan told us a minute ago it's where they cross, right? Is that the only possibility? Could you have a system that did not have any solutions? How? How do they not cross? Oh, parallel. So are these the only two solutions? Either one solution or no solutions? What do you think the other possibility is then? What do you mean by that? Can lines cross more than once? Oh no, we're just talking about lines. Okay, so what about this one? Oh my gosh is right. How many solutions do I have? All of them, right? Every point that lies on each line is a solution because the lines lie on each other. Okay, does that make sense? Okay. Now number 2. What kind of system do you think this is? So it's a 2. Oh, 2 by 2. Okay, I'll take that. A 2 by 2 system because it uses 2 variables. Excellent. Which of these ordered pairs is the solution to this system? How do I do it? The power of knowledge? Okay, how else? Plug it in. Which one? Where would you start? Either one. Start with A, okay? So 2 times 15 is 30. Negative 7 times 3, negative 21. So 30 and negative 21 is 9. So that's the answer? No. Try the other one. So 1/2 times 15, so half of 15. 7.5 minus 3. Is that 3? Is this the solution? That means this point lies on this line, but does not lie on this one. Okay? What about, would you go to B next? Okay. 2 times 8 is 16. Negative 7 times 1. So 16 minus 7. Oh, that works. But I know better than to ask you if that's the answer, because you're already giving me dirty stares. Half of 8. 4 minus 3. Oh, it works. There's my solution. That is crazy, isn't it? You have 3 to do and 4 to do. Okay? This tells you it's an ordered triple, just in case I forgot to tell you that, but I didn't. Top of this page, it uses that vocabulary. That's why we have to make sure you have it. Evaluate each equation for the given values in the ordered triple. If the values check, then shade in the corresponding box. Okay? Example. 3 times negative 2. Negative 6. 2 times 3. 6. So I have a negative 6 and a positive 6. So 0, negative 3 equals 14. If it's not true, do I shade or not? No. So go to the next point. Plug it in. 2 times 3. 6 times 2. So I have 6 and 12. That's 18. 18 minus 4? 14. Does that work? Do I shade? Shade her. You get the idea? Okay. Are we solving systems of equations here?
Ms. Kingston?
Yes?
Will you send Seth Farrington to the office for a second, please?
Yes, sir.
Thank you.
Okay. So, are we solving systems of equations here? Or are the equations or the solutions being given to us? They're being given to us and we're just checking to see if it's a solution, right? Okay? Tomorrow we'll start the solving. I'll just give you a little foreshadowing, right? Little cliffhanger, so be so excited about solving systems tomorrow. Try to stay calm. Okay? So you're plugging these in over here. If it works, you're not shading. Oh, it's shading? If it works, you're shading. If it doesn't work, you're not shading. Okay? When you get done, all the ones that are empty or the not shaded will go down here at the bottom of the page. And we'll make a quote. Any questions?